In 10.5, we're going to learn how to interpret box and whisker plots. But first, we're going to review some vocabulary terms as well as how to plot one. Okay, for a box and whisker plot, it's another data display that organizes data values into 4 groups, and it is very useful in interpreting data. So the first vocab I would like you to revisit is called the lower extreme, meaning the smallest number of a data set. Okay, and then we have the lower quartile, which I will explain a little bit later, but for now it is the median, the middle number of the lower half of the data set. And you have the upper quartile, which is the median or the middle number of the upper set of a data set. And then you have the upper extreme, which is the biggest number of a given data set. Okay, I'm going to tell you how to calculate these or identify these numbers again using this example below. Now, the lengths of the songs in seconds on a CD are listed below. Make a box and whisker plot of the song length. Note that this has an odd set of data. When it's even, then it's a little different. First of all, let's keep it simple. Order the data from least to greatest to find the median, the quartiles, and the upper extreme, which could also be called the maximum value of a data set, and the lower extreme, which is the minimum value or the smallest value of a given data set. So I'm going to start with 173, which is the smallest one. And then we have 179, and then 181, 198, 206, 239, 246, 251, 257, 261, 295. I think it would be a good idea to cross out the ones you've already listed as you go. So I should have done 173, cross it out, 179, cross it out, and so forth. And since there's an odd set of data, so we got 5 to the left and 5 to the right, and we have 239 as our median, the number in the middle of this given data set. And now, since we have also an odd number of values for your lower half, so to find the lower quartile, it would be to find the median as well. So it would be 181. So the definition of a lower quartile is the median of the lower half. Of the data set. And the upper quartile is just the opposite. That will be 257. So it's the median of the upper half. And now we're going to plot everything once we have this organized. So first of all, I'm going to plot the median. The median is around 239, so I will give you a number line here. So it's approximately about here. So this is 239. I'm going to write 239 right here. And then I'm going to plot 181, which is approximately right here. And try to align it with the dots all together. And, okay. And then the lower extreme will be 173. So it's probably around here. And then you have your upper extreme, 295, or maybe I should do the median or the upper quartile, 257 first. So that's about here. And then the upper extreme of 295. Okay, please label these numbers. And now we're ready to draw our box. Okay, so box. So here's the box. And then your whiskers. Okay. Now let's continue with the vocabs. The range, which means the difference of the upper and lower extremes will be taking 295 and subtracting 173. And that would give you 122. Okay, that's your range on how spread the data is. And then you have your interquartile range, which is the difference between the upper and lower quartiles. So that would be taking 257 and subtracting it from 181, which makes 76. Now, the outlier could be a little bit more complicated, is a value that is widely spread from the rest of the data. So a data value is considered to be an outlier if it is greater than the upper quartile or less than the lower quartile by more than 1.5, by more than 1.5 times the interquartile range. So that means I need to take 1.5 and then multiply by 76, and that would give me 114. Now to check if 173 is an outlier, okay, I need to first find out the lower quartile. I need to do 181 subtract 114, which is 67. But 173 here is greater than 67. But if this number here were smaller than 67, it will be considered an outlier. So 170 is not an outlier. And for 295 here, the upper extreme, we want to see if this is an outlier. Let's check for the upper quartile. I need to take 257, the upper quartile, and subtract 114. And this gives me 371. And since this is 371, and the upper extreme is not bigger than the 371, it's actually smaller than 371, it's also not an outlier. In order for 295 to be an outlier, like a point that's way off, it needs to be bigger than 371, excuse me, which I obtained from taking the upper quartile and subtracting it from the number 114, which I obtained from multiplying 1.5 by the interquartile range. Okay, so you need to really understand the concept behind what an outlier is in order to determine whether the points or the values are outliers or not. Okay, let's practice making a box and whisker plot with an even set of data. So first of all, let's see how many values do we have. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8. And the smallest one happens to be 1. So I'm going to put 1 here. And the next one will be 6. And then 9. And then 12. See, I'm canceling these out as I go. And then we have 13. 14, 17, 18. Okay, now this is in order. Now, this is my lower extreme, and this is my upper extreme. I'm just abbreviating these. And to find the median, now this is a little different from the last one. I need to take 12 and 13 and add them together and divide by 2 to get 12.5 as my median. Now, for my lower quartile, I need to take this part of the data. and then I have 4 values. So I need to take 6 and 9 and calculate the lower quartile because I have 4 values. So I need to take the average of the middle, and that will be 7.5. And the same goes for the upper half. So that would be 14 plus 17 divided by 2. And that would give me 15.5. Now let's plot our picture here. So I'm just going to use intervals of 2, 4, 6, 8, 10, 12, 14, 16, 18. That should cover everything. And the lower extreme will be 1. So I'm going to put a little dot here. And then my lower quartile is 7.5. Should be around here. My median is 12.5. And then my upper quartile is 15.5. And then we have the upper extreme of 18. And let's draw our box and whisker plot. And that is it. Now that you have refreshed your concept of how to draw a box and whisker plot, let's review on how to interpret one. A box and whisker plot separates data into 4 sections. The 2 parts of the box and 2 whiskers. All 4 sections contain approximately the same number of data values. So what can we conclude about this? The entire box here represents about 50% of the data. So that means 25% each for each part. And each whisker represents about 25%. So this is 25%, this is 25%. So it doesn't matter how long your whiskers are or how small or wide or narrow your box is, it doesn't matter. Each part represents about 25% of the data. And you can actually calculate a certain number from knowing this concept. So let's look at a real life question here. Precipitation, meaning raining. The box and whisker plots below show the normal precipitation in inches each month in Dallas and in Houston, Texas. Part A. For how many months is Houston's precipitation less than 3.5 inches? So I am going to look at this part of the graph. Well, actually this part, okay? And I know that this represents 25% of the data. And there are 12 months in a year. So I'm going to take 25% and multiply that by 12. So about 3 months. Houston received about less than 3.5 inches. And for part B, we want to compare the precipitation in Dallas with the precipitation in Houston. Well, for comparing, what I would like you to compare is the interquartile range and the range. Well, you can also discuss other items, but for now, just focus on these. And usually when I do comparison, I will make a chart. Okay, so for the interquartile range for Dallas, it will be 3.2 minus 2.3. And that will be 0.9 inch. And for Houston, it will be 4.4 minus 3.5, which is also 0.9 inch. So basically I took this part and subtracted 3.5. And as you can see, they are the same. So I'm going to conclude that Dallas and Houston have the same variation in the middle. 50% of the data. So basically, the middle would be considered the box area, okay? And the range for Dallas is 5.2 minus 1.9, and that's 3.3. Houston, 5.4, subtract 3.0, which is 2.4. And what can we say about this? The range is greater for Dallas throughout this year, and Dallas has more variation in precipitation. Okay, and this concludes the lesson.